All right. Hello, everyone, as you join in. My name is Anish Verma, and I will be giving you a fantastic presentation today. Um, so with that in mind, I will once again share a link in the chat in case you want to follow along um, with the slides. So let me just do that once more. And okay. Well, with that out of the way, I think we can get right into the presentations. If you have any questions at all, feel free to shoot them in chat and I'll try to answer them in the last 5 minutes or so. Um, so yeah, let me get right into it. So welcome. Let me take you along the path that I took to get to where I am today. My path through data science, where I journeyed through physics, quantum computing, medicine, finance, software development, and so much more. But why should you care, right? Like, who am I? Well, my name is Anish Ravi Verma, Anish R. Verma, and currently I am the Chief Data Officer for STEM Fellowship. Um, in addition to that, I am also a quantitative analyst as well as a quantum software developer at 1Qubit. And of course, in terms of education, I studied physics in my undergraduate as well as for my master's, and I'm always happy to talk about that and try to inspire people to study physics as well. Um, so with that, what's this presentation going to look like? Well, first, I'll run you through my education from high school to undergrad to my master's, and then into my career. So what I do, what a day in my life kind of looks like, and then finally, the applications of data science and things that you might want to do, whether it's in physics, whether it's in medicine, finance, or just about anything really. All right. So first, education from high school to grad school. So in high school, I actually wasn't anywhere near a standout character, right? Sure, I had pretty decent grades, but I didn't do anything notable in terms of extracurriculars. And truly, I had no idea how to code at all. Um, and with that, I was kind of just confused as to where to go. I applied to colleges, um, and I just wanted to see what I might want to do, whether that be physics, English, or something else. Um, but really, I knew that one of my passions was in physics. I wanted to understand how the universe works, right? I wanted to see what we could do as, these little like specks of insignificance in the vast universe that there is. Um, so, I applied to a bunch of different schools. Like, I got accepted to quite a few just because of my, well, luck, really. And I did get rejected from a couple different schools, one of which was McGill over in Montreal, Canada. But, you know, I I decided basically on I decided basically to choose whichever one I saw as giving me the most opportunity. And for me at the time, this meant which school had the most like job opportunities, as well as the one that gave me the most scholarship money to pursue my studies. Um, so I decided to study physics at Simon Fraser University here in Vancouver, Canada. And here you can see me with a beautiful little telescope, looking off into the stars. And secret of the trade for this picture, those stars in the background there, they're photoshopped. um, but yes, one of the things that really, I guess, taught me where I want to go, really like made me think about what I want to do, was getting involved with academic research over in over at SFU. And basically here was where I was able to take all of my textbook knowledge, right? All of the paper pen, all the equations and all that fancy stuff and actually contribute to the world, right? Push further the bleeding edge of science. And it was here actually that I really learned how to code. Um, you know, when it comes to the research that I did, I basically looked at nuclei, so protons and neutrons, and the things that make up the entire universe, and specifically how we can mathematically model them and understand them as well as the fundamental physical forces of nature. And this picture here is actually just a toy diagram of a rotating ellipsoidal nucleus, with described as some equation up at the top there. It isn't important for you to know what it means, but all you need to know is that this thing really forced me, pursuing research really forced me to understand the material that I was learning, to learn how to code, and really launch myself. Right. As well, for anyone that's joining the chat, I will be doing my best to answer all the questions at the end of the call. There should be 5 or so minutes for that. But yes, continuing forward. Thanks to this, I had so many opportunities, and a lot of them involved, traveling, presenting at conferences, publishing my work, getting scholarships. And it's something that I recommend that you pursue, right? Whether you pursue research in medicine, in physics, and chemistry, in computer science, whatever. I think that it's a invaluable opportunity that anyone should look into pursuing. But like I said, in high school, my extracurricular was quite poor. I didn't do anything, and I think this was in part because I was so shy at the time. But in university, I felt that like I was flourishing when it came to academics, and research stuff like that. But I found a sort of a sense of community, and I really wanted to contribute to that. And for that reason, I decided to pursue some extracurriculars. In these three pictures are just a few of the things that I did. In this top left or middle left over here, I was basically helping uh, lead the incoming freshmen every year into the Faculty of Science and getting them familiarized with the community. In the bottom middle, it was sort of a cute little formal event that we put on to sort of commemorate and honor like every student's hard work throughout the year in all the different faculties. And then in the middle top right, that's one of the things I'm more proud of, where we started an undergraduate research journal, which basically allowed me to network with so many people and understand the nuances of how to communicate and network properly with people that are far out of my league at the time. But beyond extracurricular and all that stuff, all of this culminated in the fact that I ended up being the valedictorian for my graduating class, which I'm again very proud of. But at this stage, what I've told you is that in university, I went from not knowing anything, not knowing what I wanted to do, to really being catapulted into exactly knowing where I wanted to progress, right? Knowing what I wanted to do in my career, all thanks to not my schoolwork, but my extracurriculars, as well as my academic research. And once again, I think that it'll be these two things, research and your extracurriculars, that will make you stand out when you're applying for jobs, applying for medical school, and so on and so forth, other than just, getting good grades. But then what's next for me? Well, that's when I decided to pursue grad school. And in grad school, I was like, whoops, whoops. In grad school, I was like, well, I really did enjoy physics. And I really did think that just seeing how far it catapulted me, I really, really wanted to continue on with that, right? And really hone my skills. So in grad school, I ended up pursuing a master's where I looked at what's called infinite nuclear matter, which is basically just a fancy way of saying there are a ton of protons and neutrons. Let me try to address them all at once. And this is where I learned like hard or more robust computational methods, right? So I went from basic data analytics and mathematical modeling in my undergrad to actually being able to use these like massive supercomputers in order to do the things that I do. And that bottom equation there is basically a quantum mechanical equation that is the basis for pretty much all of quantum mechanics, but it applies very, very well to everything that we do at the quantum level in physics. But sure, all I've said so far is that I studied physics, right? I did my master's, but so what, right? How did I get to where I am today? How did I get to my career? Well, first, I think it's important to quickly just look back and understand what happened. Um, and really, really, I just want to say, like, for you as high school students, focus focus really on those extracurriculars and meeting people. It'll be the best way for you to sort of launch pad yourself into any career to learn new things. So now career, one qubit. Well, what do I do at one qubit? What is one qubit? One qubit is a quantum computing startup where we're trying to make intractable problems, it's really difficult problems, into easy ones using quantum computers. And one of the things that we're doing right now is we're applying these statistical and data science related models and combining that with the power of quantum computers to solve like super difficult calculations from everything from medicine to finance to quantum simulations, right? So physics, stuff like that. And all this is to say, I was able to leverage my abilities and my education in physics, along with my passion for these real world problems, to a natural progression into data science, effectively. So, one of the things that we're doing right now is creating these tools using quantum computing and quantum inspired methods to forecast the financial markets. So if anyone here is interested in things like finance, in things like economics, this is something that you might be interested in pursuing using data science. But that is what it is. Now, on the quantum side of things, I really want to stress that, despite working more on the finance side now, all of my education, all of my experiences were able to be leveraged and used within the current domain, within what I'm currently doing. Um, so yeah, exciting stuff. And all of that is to say that no matter what you study in your undergrad, right, in your master's, PhD, MD, whatever, right, you can always find ways to utilize those skills into anything that you want to do as long as you have a passion for it. But, now I want to talk about something that's a little bit more relevant for you right now in high school. So right now I'm also the CDO or Chief Data Officer for STEM Fellowship. And in short, the organization just wants to provide to you resources and programs that will allow you to grow and learn data science and all the skills of science in ways that weren't available for people like me back in the day, back in like early 2010 when I was in high school. Um, and one of the ways that we do this is through my data science committee, where we put on these spectacular experiential learning programs for the high school level and the undergraduate level, which is most relevant for you guys right now. And of course, within these programs, we teach you the fundamentals of data science as well as how to actually use them in a real world setting, right? So how to learn and use data science to solve problems within your community and the global community at large. And I've shared the slides, and within there is a link to and how to pre-register for this year's high school challenge, which I invite all of you to pursue later on. But beyond that, right, if you want to learn more about us, feel free to head over to the slide deck above and click on any of the links, any of our social media to learn more about it. Um, and again, I'm sort of rushing through this last part now, but I really want you to if you're interested in learning about data science at all in an applied way over a long period of time, I thoroughly encourage you to pre-register for this event. Now, data science applications, the thing I promised you at the very end, since we only have a few minutes left and I want to focus some time on answering questions. What can you do with data science, right? What can you do with all these different fancy charts and figures and all these computational tools? Well, you can do just about anything, really, right? I already talked about physics, right? My research enabled me to really explore fundamental physics, right? To create these nice physical models that can be tested at these big particle colliders like CERN and Triumph, and really find a way to understand the physical universe. And it really, in order to communicate these ideas to the world in publications, we use simple data visualization techniques, right? Like in here, we have a 3D histogram that tells you about the evolution of nuclear matter, right? You can learn the fundamentals of the universe through data science. You can explain that to the world. And I think that's pretty cool. But what if you want to do something more on the quantum computing side, right? More on the comp sci side? Well, there are a ton of things you can do. A lot of the time, people are working with these huge, massive sets of data, right? These intractable data sets that take forever and a half to run on a classical computer. But using quantum computing, we can exponentially speed that up. And here, this is basically just showing that you can take like a super big, vast data set and apply some machine learning methods that are amplified and enhanced using quantum computing to reduce your data set basically to these principal components or to these clusters um, that you can then analyze for simple things, right? Like identifying age, histograms, stuff like that, and important factors that someone might care about in creating, for example, a software to identify relevant factors in the diagnosis of illnesses, right? Speaking of which, machine learning in medicine. One of the really cool things that ways you can use data science is through machine learning and image processing. So there are a ton of data of these scans that happen every day in hospitals. And a doctor's job is hard, right? They only have so many hours in a day. They only have so many people on hand to help them. And using data science, we're able to help these doctors diagnose patients better and more efficiently. So pictured here is actually a software that basically uses machine learning to help identify um, anomalies within these lung scans to help diagnose. Which is, I think is phenomenal. We're able to use technology in ways that we didn't even dream of, 10, 20 years ago. Um, Another quick way to use it, just because I'm running out of time here, is to use machine learning and data science in order to interpret language. So here I'm applying it back to the financial markets, but basically we're able to use techniques like sentiment analysis. So literally running these machine learning algorithms through, or pardon me, running like text, right, like tweets, press releases, stuff like that through these machine learning algorithms to get results and understand how people are feeling, basically. And using that information, we're able to apply that, for example, in the financial markets and understanding how exactly we can potentially predict like swings in prices. But of course, you can use this for other things, right? So like understanding the impact of, for example, the president's tweets when pushing out or when understanding vaccines or alternatives that were proposed that just aren't scientifically backed up to combat misinformation, basically. So misinformation. I think this is the last thing that I wanted to show you before I answer questions, since there are 3 minutes left. Um, so with this, we're actually able to, with using data science, right? We're actually able to take a look at all this big data, run our algorithms, right, and really understand and predict in a sense the way that not only the virus and how it will spread, but also how public sentiment and feelings will spread, how misinformation spreads, so that we don't have a repeat of like toilet paper hoarding back in the day. um, yeah, so all of that is to say that you can do all of this. And once again, I'm gonna promote our program that's gonna happen in November, where you can learn data science skills. Um, but yes, now that we're at the in the last 2 minutes, I want to just quickly rush through all the questions. So I will do that right now. So let me just stop sharing my screen, open up the questions. First question, what do I plan to do in the future? My plan for the future is to make impact in any way I can, whether as long as it's something I'm passionate about, which I know sounds vague, but I think I've proven to myself and hopefully to the community at large that I really can make impact in whatever I choose to do, thanks to my education and training in data science. When did I learn coding? In second year undergrad. So again, pretty late. I was so far behind where all of you guys are now just by attending conferences like these, because these opportunities weren't there. Uh, do you know of any resources that discuss data science integrating enhanced physics? Blah, blah. Yes. So basically, data science goes hand in hand with any science, right? Um, in terms of resources, I think you should just look at any online course that covers data science or scientific programming, and you'll get a ton of traction there. Um, so quickly, I will post the link to the pre-registration of the event. Um, Okay. Where do I live? I live in Vancouver, BC, Canada. Do you have any advice for getting a mentor to enable academic research for science fair as a high schooler? Yeah, for sure. Oftentimes there are programs like REOs that basically are there just for you to gain experiences like these. So, and honestly, some profs even don't mind getting cold emails from students that are interested. All right. How do you feel about where you are today in your profession after all you've been through? Very happy. I think that's the best way to put it. Um, I think data science has enabled me to do so many remarkable things, and that's where I am today. Right, so I'm just going to go through the last of the questions before I end, since I was limited to 20 minutes. Um, do, 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 take photos. Do you know if any asked that question? Transparency, not today. Impressive. How do you feel? Okay. Yes. Feel free to connect. Okay, perfect. That is which college did I graduate from again? For undergrad, I graduated from Simon Fraser University, SFU. All right. And from a master's, I studied at University of Guelph and the University of Waterloo jointly. Okay. I think that brings it to a close. But if you have any questions whatsoever, feel free to scroll back up in the chat, look at the slide, and connect with me on any of my social media through email, whatever you want. And with that, I wish you a fantastic day and goodbye, everyone.